And here we go. We have liftoff. Propulsion continues to be nominal.
R68 chamber pressure looks good.
Doubling up. Roger, roll, Atlantis.
Water towers fly! Yes!
Tango down to nominal.
Flight downside SPD off. Bring in SPD off. Off. It's orange!
Oh my god! Oh my god!
Decollage.
Look at this!
Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
The methane would be igniting the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.
Good evening. You are taking a live look right now at Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida, where SpaceX is set to try once again to launch the Astranis mission from one to many. I am Sawyer Rosenstein, and I will be your host for tonight's launch attempt. I see all of the 5x5s in chat, meaning that you can hear me, but thankfully you won't have to hear just me tonight. Of course, when it comes to Falcon 9 facts, we have the fantastic Alex. How's it going, Alex?
Well, I don't think it improves the experience a lot, but yeah, I can help a bit with the Falcon 9 facts.
Just a few of them, huh?
Yeah. Hello, everyone.
And then from the field, joining us tonight, we have Julia. How's it going, Julia?
Hey there, Sawyer. It's going magnificent. It is almost Sunday, which means it's, another launch night. And I'd like to say it is as beautiful as it was the first time we tried to launch this mission. It is a little breezy, but hey, I'm enjoying it all the same.
Any day that ends in AY is a good day to launch in my books. So we are, as we said, this is once again a launch attempt of the Astranis mission. Alex, can you kind of give us a recap of why we're trying again and what actually happened on that first attempt?
Yeah, we got into a launch attempt a few days ago with this same mission, same payload, but different booster. That was B1077 actually. That was being used for that try, and we had an abort essentially at engine ignition. We're doing that replay of that abort here from back then. I'm trying to time also my whole commentary around that abort. But essentially, the engines ignited, right? Just like you would expect ahead of liftoff, and there was no liftoff. The engines shut down, and we went into the usual detank and scrub mode and everything. So we have not had any information, though, unfortunately, on what caused this abort. All we know is that they switched boosters.
Yes, this is a different booster on the right side of your screen than the one on your left, which Kevin Michael Reed, producing the stream, thank you for pulling up the replay. Also, the view that you see on the right side of your screen currently is from D out in the field. We will also have views from Max Evans coming as well. But yeah, this is a different booster. Julia, what booster are we flying this time?
Well, Sawyer, let me get back in my phone here, but tonight we are actually flying booster 1083. It will be this booster's 7th mission. The first mission it flew was Crew 8. It's also flown Polaris Dawn and CRS-31. The other missions were Starlinks. So primarily, this is kind of a half crew, or shall we say, Dragon booster and half Starlink booster. And now we're going to add one more mission, which is a commercial mission to its roster. A little bit different than the booster we had before, but probably necessary due to the circumstances. To give a little bit of insight, watching when there is a after ignition abort, we all kind of hold our breath when you're this close to a rocket. It's just one of those moments where you're expecting it to go, it doesn't go, and we all kind of stand there and go, well, okay, well, it looks like it was safe. So yay, because, being this close and hoping things are safe is kind of interesting.
Yeah, that is a good point. They do have to make sure that they safe the vehicle if there is, especially if there's edge ignition at that point. And I know you are currently located a little under 2 miles away from the pad, so the potential consequences could be rough. But again, this is the second time the SpaceX has had an abort at engine ignition this year, so they're kind of good at it. Also, I want to point out on screen a couple things that you see there for the facts on it. Besides that, it will be landing downrange on a shortfall of gravitas. Look at that turnaround time. That is 29 days. That is not just being vague. That is 29 days, 0 minutes, and 0 seconds, right, Alex?
Yeah, it supported that Starlink 665 mission, that last one in that booster history list, and that was right at midnight as well. That of course implies that this mission is launching at midnight. The window today is 2.5 hours long, so if it goes into the window, then well, we'll also have to change the turnaround on there. But you know what has changed as well?
What?
The camera view. Look at that. It's different.
Yes, this is from Max out in the field as well. Our Cape team back out in full force with fantastic views for us this evening. We are excited for a great launch here. And a reminder, if you have any questions during or about this launch, you can tag us at NASA Spaceflight, and we will do our best to answer as many of your questions as we can here. Which I saw someone asking about the trajectory. Alex, which way is this going tonight?
That is a great question, and it's usually this little trick that I usually say on these streams, especially when there's a GTO launch like today. This 4 satellites that they are launching are going into a geostationary transfer orbit, which means they need to go to the lowest inclination possible, because the lower your inclination, the less effort that the satellites need to do in order to get into equatorial orbit at geostationary altitude, right? And so the easiest way to do that is just launch straight out of the Cape. That gets you the lowest inclination when you go into the parking orbit. So that second stage will first enter a parking orbit, right? And then over the equator, it'll burn again about 26 minutes into flight to put these satellites into that geosynchronous transfer orbit. So that's sort of the profile for today. But yeah, there you have that graphic with a launch trajectory for today, straight east. It's very easy for these missions. If it goes to a GTO, it's always straight east. Very rarely you'll see any exception to that rule, I guess.
And the other interesting thing to note also is that normally they'll publish what the re-entry profile would be for the second stage.
Mm-hmm.
There is not one for this, correct?
Yeah, so for these missions, the second stage is just left in the same deployment orbit. So that deployment orbit is like this egg-shaped kind of orbit where the apogee is at that geostationary altitude, and then the perigee is sort of like LEO altitude, low Earth orbit altitude. And the reason for that is because the second stage does not have enough performance to then, turn around in the orbit from that orbit. In theory, it could, but then it will need like an extended mission kit and things like that. Like it will have to go all the way out to apogee, which is like 6 hours of coast time and everything. It's a lot to do, and oftentimes you just reserve that extra performance to give a little bit more of a boost to the satellites. And sure, that leaves the second stage as space junk. Let's be clear, right? Like that's not a controlled thing up in space, because once that thing just they passivate the second stage, as they call it, essentially blowing out all of the remaining gases, draining the batteries and everything, right? And it just stays up there in that deployment orbit. But as it passes, because as I was saying, it's an oval shape kind of orbit, so the perigee, it's close enough that it passes by the atmosphere, very rarefied atmosphere, of course, very thin atmosphere, but it passes by, and so it gets a little bit of a drag every time it passes through that perigee, that lower portion of the orbit. And so over time, it'll eventually come back many years down the line and uncontrolled, but at least it'll come back.
There you go. So no planned re-entry for that, but if you're planning to see it, here is a great map that we have made by Mr. Map Ryan Caton to give you an idea of exactly where and when to be able to see it. So if you're within that red circle at the T plus time that you see on the bottom, that is time after it lifts off, go outside and take a look, especially with this one going due east, a great launch for anyone, anywhere for the most part in Florida, especially towards the eastern coast. We talked briefly about them, but in terms of recovery assets, Julia, what do we have downrange?
Well, today we have a shortfall of gravitas, or ASOG. That is the drone ship that will be recovering the booster, and Doug is downrange to get those fairings. So, yeah, really not much else to say about that except for I really kind of hope we get another drone ship soon if we're going to keep this cadence up.
That is true. Which there was a question, by the way, from Mike Phelps, perfect for a swimming question, I guess. Are all the drone ships updated with a water deluge? Do you know, Julia?
I honestly do not know that answer. Now they've always had, maybe not necessarily a deluge, but there has always been a water system on deck to at least spray down the deck ahead of the booster landing. So, but I'm not sure if just read the instructions has gotten that one yet, as far as the same equipment that ASOG has gotten. To be fair, the drone. Oh, is it the other way around? Really?
Yeah, it's just read the instructions, the one that got the water deluge. We call it water deluge, but as you were saying, they used to have these hoses, right? That they used to use for hosing down the. But it seems like maybe they try to optimize it, right? They tend to do this all the time, especially with the recovery and launch weather and launch hardware.
Right, and the thing is too, the drone ships are not in port very long to do any major upgrades, just because it's a little over 2 days out, a little over 2 days back. They drop the booster sometimes right on the deck, right on the dock, and then they resupply and get gone. So they're not really sitting in port very long to do a lot of upkeep, shall we say.
Yeah, and right now, actually, there are no SpaceX drone ships at port because the other one, just read the instructions, will support tomorrow's Starlink launch from the Cape. There's a drone ship, though, and you can kind of see it there on the right-hand side view on the left of that view, but that's not for Falcon, that's for New Glenn.
Yes, which we had the static fire of the other day. And then it seems like that's the case as well for, of course, I Still Love You out in Vandenberg, by the way, too, because they mentioned that they didn't really see it earlier on the stream out of Vandenberg. Which, that's worth pointing out. While you couldn't see it on the pad, shocker, I know, crazy how much better the views are on the East Coast, Best Coast of these Falcon 9 launches, but there was one, Alex, out of Vandenberg earlier.
Yeah, they are doing 3 in just a couple of days. You know, that's actually how it all lined up with the crazy schedules. Actually, today's launch should be the penultimate one of the year. Although, you know, knock on wood, right?
Yeah.
It's not the last one of the year. But yeah, we'll have the last one tomorrow with that Starlink mission from 39A. Currently not out there yet, but you know, it's still in the hangar. Gonna get there probably in the afternoon.
But at least we have another one coming up. And yes, see what I mean? Take a look at the difference. On the left is the left coast, on the right is the right coast. Tell me, which coast has better views for rocket launches? Huh.
Yeah.
Yeah, exactly. East Coast, Best Coast, Jack. I don't even know if Jack's
You know
watching,
what?
but yeah.
I heard a fun story this evening as we were getting ready to roll out for launch viewing tonight. One of the gentlemen that actually volunteers for the 45th at the History Center and the museum, used to work out at Vandenberg, and he told me he worked over 30 missions launching satellites back in the day, and most of the time you couldn't even see the rocket from the blockhouse. So there you go.
Oh my gosh. And it's not like it's important or anything to be able to see your vehicle.
No, you hear it and you hope it stays up there. That's basically the story of Vandenberg.
Oh, that is so perfect. But yes, that was the launch that you saw from earlier today, which I guess was not your ordinary Starlink because it's the last one of the year from the West Coast. And this mission, absolutely not your ordinary Starlink because it is not a Starlink. And I don't think we've talked yet about the 4 payloads that we have aboard this flight. Alex, can you break down what is actually flying on this Astranis from one to many mission?
Yeah, so they are launching 4 different satellites, and this is sort of a departure from what you will see on a GTO mission, right? On a GTO mission, usually what you will see is like this big 5-ton satellite, being launched into that orbit, and then once it gets into geostationary orbit, then the satellite, it has like dozens of transponders and antennas and beams going down to the ground, and it covers like an entire continent or maybe half of one continent and another half of another one. That's usually what you will see, right? This is completely different in that mindset, in that sort of way of working. So instead, we have 4 smaller satellites, around 400 kilograms each, and these are what they call MicroGEO satellite bus at Astranis. And what they do is that instead of having to cover an entire continent, they just cover like a smaller portion. And so they still have the same, antennas and whatnot, but in reduced numbers. And so they can concentrate all of their, transmissions and connectivity stuff on just a smaller region of the world. So, they can actually be, custom made to the actual mission that they're going to be doing. So that's the case for at least 3. I'm going to get to the 4th satellite. I'm going to go first to the first 3, which are actually a little bit more like this. 2 of them are, you can see there some of the patches for that NuView-A and NuView-B. Those are, Q-band, high-speed throughput connectivity and things like that. That one, I believe, is going to be for North American and Caribbean connectivity, and especially for planes, as you can see there on the patch, it's about connectivity on planes and things like that. Then the AGILA, I have really not been able to know exactly what's the pronunciation of that one. It's pretty much like in Spanish as well, so it probably doesn't help. But yeah, that one is also this sort of connectivity satellite for the Philippines. In that case, it uses an older. So this company, Astranis, they were building a satellite for another company for in communications and connectivity in I think it was Peru, because it was in Peru, and so that was the Andesat 1 satellite, and then they changed the purpose of that satellite for this mission because they the other mission delayed and everything. So what they did is they changed that satellite to speed up this deployment for this other company, which is Orbits Corp, and to serve the Philippines instead of serving Peru. Now, the 4th satellite, though, is UtilitySat. So I said, each satellite, it's smaller, it concentrates their efforts in just a smaller portion of the globe, which means you can essentially just do things for whatever, like, you're maybe helping connectivity in planes, maybe you're helping connectivity in rural areas. You can adapt the satellite and make it, because it's just a smaller region of the world, you can just essentially make it so that it is adapted to that work. However, Astranis was like, no, we're going to do something even cooler. We're going to take this versatile and small sort of satellite concentrated in a very small region of the world, and we're actually going to make it so that we can adapt it. We can transmit different frequencies with different antennas and different software and everything, right? And that's UtilitySat. So you can have, K-band, Q-band, Q and V-band as well, connectivity, like multiple different frequencies. And that way you can essentially pick that. So, you may have like a 2-year mission with that satellite, for example, just to put an example, on one slot on GEO, right? Maybe over the Philippines, for example, just to put a country. And then you want to move it to another part of GEO after 2 years. And then you want to have connectivity in another frequency in Chile, for example. So that way you can adapt your satellite, and it's not, again, this giant monolithic satellite working for 15 years, always on the same spot, maybe moving a little bit here and there, but that's all you've got out of there. Here, at least, you got a lot more versatile options, and so that's more or less what they're, that fourth, as they call it, UtilitySat, that fourth satellite, it's called like that because it is, again, it's very versatile, and so it's utility.
Now that's what I call Alex answers, available now at the shop.nasaspaceflight.com. I joke, of course. But yes, that is a very good detailed answer of the 4 satellites that are on board. And hopefully, the other thing that should be on board Falcon 9 very soon is propellants. If all is go for this attempt, then propellant load should be starting right about now, in fact, at the T-minus 35-minute mark. As always, they begin loading with the liquid oxygen, the LOX, and the RP-1, the rocket propellant 1, which is a refined form of kerosene, into the first stage simultaneously, while the second stage just begins with the RP-1, which is closer to ambient temperature than the super chilled liquid oxygen. So they will load that up, they will purge the lines of what we love as the T-minus 20-minute, 20-second vent here. And then following that, about 4 minutes later, they will begin loading the liquid oxygen into stage 2. All that neatly outlined for you there on the left side of your screen with the countdown timeline, hopefully culminating with liftoff at midnight Eastern, 34 minutes from now. Again, this is the Astranis From One to Many mission, and there are many of you that are supporting us, which is why we're able to do what we do. David, thank you for becoming a PadRat member. Mac McCormick, thank you for becoming a Red Team member. And Rob Webster saying, I think it's time to change from attempting landing to landing on a shortfall of gravitas. That would be like saying attempting to launch now. You say that, a reminder that this is the second attempt for this particular satellite launch, as the first one had abort at engine ignition. That is why we continue to say attempt. All I need to say is bullseye or bingo right in the center.
Yeah.
From a certain V-62 mission, which is why we continue to say attempts. Because, again, it's spaceflight. Spaceflight is hard. I know people hate that saying, but it's true. Especially when you launch this many times, there are times where things are not going to go completely nominal. So everything at that point is technically an attempt.
I mean,
yeah, let's not tempt the fate.
wow. That was, yeah.
That wasn't me, Julia.
All I was going to say was, I mean, eventually statistics may catch up to you because you're launching so many times. So hopefully they never do, but that's always a possibility.
Exactly. And we did have the question, David asking, as we get to what is expected to be the penultimate flight. Alex, how many missions will SpaceX complete this year?
If they do tonight and tomorrow's missions, that should be 138 total. For Falcon, that will be 134 because, of course, there's been 4 Starship launches as well. So, but in total, 138.
There you go. Not bad. Again, a little under the 144 plus the 4 makeup from last year that they were aiming for, 148. But Julia, being out there in the field and being around for most of these, the cadence still feels absolutely bonkies, to say the least.
Yep, it is a bit bonkies. And one of the things that I had tweeted last night was that if you took the amount of launches anticipated to complete the year, and figure out the average, that's 2.72, I believe, days per, like basically 2.72 days is the average for launches for SpaceX right now. And it feels like that. It's really weird when there is a week where there isn't a launch, because that week suddenly feels like almost a month when you're used to seeing 2 to 3 things launch in a week. So yeah, the trick is, how are we going to get more out of the next year, right?
Yeah.
Starship's going to contribute to that. Maybe, possibly some more RTLSs, some really blessed weather here on the Space Coast and at sea. And perhaps Vandy will be ramping up their cadence as well.
And speaking of the weather, hopefully blessing us, the weather forecast for tonight per the 45th Weather Squadron is 85% go, the only concern being the cumulus cloud rule. If for some reason they did not launch tonight and were to go for a 24-hour turnaround, the weather decreases to only 60% go. I'm being very careful this launch with my wording. I am trying to prevent a repeat. Don't worry. And also Kevin's producing, so hopefully this will go. Exactly 30 minutes from now is the scheduled liftoff time now of the Astranis from one to many mission, with the 4 satellites on board. These going to geostationary transfer orbit with this launch. You can already see fuel load underway based on the frost forming at the base of this booster, which is a different booster from the previous attempt, which they tried to launch and there was an abort after engine ignition. So this is booster B1083, ready to launch these due east. And there's your
And
recap for those just joining.
and another thing, because Julie was talking about, that 2.7 sort of average launch time, time between launches. And one of the interesting things is that from this pad, from Slick 40, they have only launched 12 more launches than last year. Like, it's not a huge increase, like just an extra launch every month, right? But from the other pads, they have done an incredible amount of work to try to be able to get more launches out of them. From LC-39A, for example, they doubled the amount of launches this year than they got, even at the previous record of number of launches from that pad. We've also got a lot of more launches out of Vandenberg as well. And hopefully once, Space Launch Complex 6 becomes a line for Falcon, then that'll be even more launches that they can do out of there. But yeah, I will agree that we should probably see some interesting turnarounds with, all of the recovery assets, because that's probably going to be our limiting factor next year.
You know what, though, Alex? You know what's really cool is that this will be the 92nd launch of the year from the Space Coast tonight. So 93 tomorrow night, which means next year we should achieve 100 launches from the Space Coast, probably no problem, right? And now looking back, this would be the first time this coast has seen 100 rocket launches in a year, which is pretty awesome. The only thing I can think of that may have beat that would be kind of our undocumented times out here at the Cape, which was our missile years. We don't exactly have the best records to tell you how many things flew off this coast back in the 50s and early 60s, but safe to say that 100 probably is a new record for us out here.
Especially if we're talking orbital. Many of those had a trajectory that was not meant to go into orbit, shall we say.
Exactly. Think ICBM.
Yeah.
Things that launch from mobile launchers, those are the ones we didn't really count. Thank you, Army. And yeah. So yeah, orbital. That's the key word there. And we're throwing more launch providers into the mix again with this coming year, with Vulcan ramping up cadence and Blue Origin's New Glenn taking flight. There's going to be no problem achieving 100 launches from here.
And I know I mentioned this on a previous stream, but a couple of years ago, the Kennedy Space Center Visitor Complex started doing a thing where on the bleachers for one of their public viewing sections, if you purchase a ticket, but if you drive by, they have launches this year. And I remember the first time they put that up, and I think it was like 40 something or 50 something launches that year. I was like, whoa, that's a lot. The fact that now it's got 90 in front of it is crazy. And then add in the fact that next year they're going to have to add a third slot for numbers. There are currently only 2. It just goes to show the pace at which things are picking up at the Cape, and I absolutely love it, and I'm totally here for it. You mentioned Slick 6, by the way. Heisenberg is asking Alex, West Coast Falcon Heavy from Slick 6?
Well, that's what we hope to see, right? In the next year. Right now, I think it's still under lease until the end of the year, like literally a couple of days from now. They'll probably be able to start works in there because it'll be the new year, so the lease will expire and everything. But yeah, right now they are also underway with paperwork, with environmental paperwork. But hopefully in the future we're gonna get Falcon Heavy out of Slick 6. Probably Falcon 9 first, and then maybe modify things for Falcon Heavy. That's what I would expect.
And for those unaware, the Slick 6 is Space Launch Complex 6 out at Vandenberg in California that previously launched the Delta family of rockets, in particular Delta 4 Heavy. However, that rocket is now retired. Don't tell Adrian, he's still very sad about it. So SpaceX currently occupies Pad 4 East out there, 4E. They now will take over Slick 6, and hopefully we will see more launches, hear more launches out of the West Coast.
Yeah. I saw someone asking, but Vandenberg isn't for polar. What would you... And yes and no. You can still launch to mid-inclination. For example, SpaceX always launches Starlinks out of there to 53 degrees, for example, which is... It's far from polar, I will say, right? It's sort of like in between mid-inclination kind of thing. In fact, they also launched recently that bandwagon mission to 45-degree inclination. So you can launch other missions. What you cannot do is, like today's mission, going to a geostationary transfer orbit, unless you want to land the booster in Arizona or something like that, which I don't think you can.
Now, Alex, that would be a dream of being able to launch over populated areas, and last I checked, that's a no-no.
I mean, if in Florida they have the Southern Polar Corridor, why can't Vandenberg have the Eastern GTO corridor?
Yeah, no, because the dogleg it would need to do so very quickly is probably just not possible due to physics.
I mean, we've seen Japan's rockets do some pretty hardcore doglegs, but yeah.
Yeah, not this kind.
That is true. Couple of questions about the view that we had. In the wider view, we saw the green rotating lights, Julia, what are those lights? And also asking about the golf balls that are kind of over there as well.
Green rotating lights. Let me turn around. Oh, those are think of them as traffic lights for the SpaceX payload processing facility there. So green means that it's a safe zone as far as chemicals and hazardous things are. Now, if they're doing a fueling process for a payload, such as think like hydrazine, those may flash yellow or red just to keep people away during that process. So that's the green lights. Those are your basic traffic light kind of signals. Now, you are seeing, I believe they are just radomes. They are not related necessarily to the launch pad or necessary for launch. In fact, I don't think we've ever determined whether or not those are SpaceX's or if they're the Space Force's. But they're not entirely close to their launch pad. They're closer to the PPF, but our view may be a little deceptive there for you.
Exactly. And what's really cool about this launch, by the way, as we see Falcon 9 there, is this is the third vehicle that Astranis will have launched on. Their demonstration sat, demo sat, launched on an Indian PSLV, and the other one launched on the Viasat mission from Falcon Heavy. And what's really cool is, check this out, the people at Astranis were checking out NASA spaceflight during that Viasat launch. So a shout out to the team over at Astranis. We've had a couple of them here in chat watching the stream. We appreciate everyone who watches us, and hopefully we provide great views and great information about your payloads. So shout out to them. And yeah, don't forget, you can watch it at any time just like them too. We have our Space Coast Live 24/7 feeds here, where you can watch all of the comeuppance at the Space Coast whenever you so please. We also have 24/7 views of Starbase, as well as for McGregor, where they do SpaceX engine testing. Not Vandenberg, because East Coast, Best Coast. Well, one thing that may not be 24/7, but that we tend to see on a regular schedule is indeed the T-minus 20-minute, 20-second vent, which should be coming up momentarily. Alex, what is this vent?
Well, that vent is for the chill down of the line for the liquid oxygen load on the second stage. So, as you were talking before, right, the Falcon 9 uses kerosene and liquid oxygen, right? The kerosene is a fuel, liquid oxygen is for burning that fuel. And one of the things is that the second stage, it gets loaded first with RP1 with that kerosene, and then they wrap up that load and start loading the liquid oxygen. Not through the same line, but the liquid oxygen line, though, it was at ambient temperature until very recently, and it needs to be chilled down, because you're going to be, they're going to be loading liquid oxygen in just a few minutes into that second stage, so that line needs to be conditioned and chilled for that liquid oxygen load in about 3 minutes from now.
And
fun fact.
Go for it.
Sorry. Fun fact, though, that T-minus 20-minute vent can give you a good idea of what the conditions are out here on the Cape. The first attempt we had of the Astranis mission, it was a very still, kind of quiet night. The water was glassy in front of us, and that T-minus 20-minute vent kind of just hung in the air. Today, you can see that vent is getting blown to the west. So we definitely have the Atlantic breeze today.
And that's exactly what I was about to ask you, so that was perfect. Almost like we've done this a few times. Here's an interesting question. As they do that vent with the completion of the RP1 load, River Dave is wondering, this is very much an Alex question, since regular kerosene doesn't need cooling to be liquid, do they cool it down so that it doesn't warm up the LOX?
In order for it to not warm up the LOX, it will need to be frozen solid, because the liquid oxygen is very, very cold. It's loaded essentially at minus 200 degrees Celsius on Falcon 9, and the kerosene, anything that is above minus 200 degrees Celsius, it's going to feel warm to that liquid oxygen. So the, cooling the kerosene to keep the liquid oxygen from warming up, it's not really possible. But they do cool down the kerosene, but not for that reason. They cool it down because they can get a bit more density out of it. They increase the density of the kerosene. And that means for the same amount of volume, you have more mass. And what you burn is the mass, not the volume. Side note here, I usually hate when some companies go out there and they say, oh, our rocket tanks can hold this amount of gallons, and it's like, yeah, but gallons are a measure of volume. And I actually want to know the mass that you can hold on those volumes, because that's what you burn. You burn the mass of that. And matter of fact, SLS has huge tanks, but its core stage, when fully loaded, it's really lightweight. And actually the liquid oxygen tank, which is like a fifth of the size of the hydrogen tank, it still has 10 times more mass and stuff like that of the hydrogen. So Yeah, it's one of those things that I really normally don't like. But yeah, they do densify that kerosene. They cool it down, I think, to -7 degrees Celsius, to be able to get a bit more performance out of the rocket.
You hear that, launch providers? Send Alex your mass, not volume.
Exactly. That's what it is on the delta V equation. You get mass. You don't put in any volumes. They don't work that way.
Any launch providers can send that to our socials. That's at NASA Spaceflight on X, also NASA Spaceflight on Facebook, NASA Spaceflight _IG on Instagram. Send it to us. I mean, you could also follow us on the socials too, whoever's watching, and send us messages there as well. So join in on the launch providers, but make sure if you send numbers, it's in mass. That vent, there you go. Some of those socials on the screen that you could see. That vent should be wrapping up right around now. And once it does, there you go. Again, almost like we've done this a few times. With that, we should see the liquid oxygen now beginning to load in to that second stage. Let's do a quick little update here for those who are just joining. Again, this is the Astranis From One to Many mission. On board, there are 4 different payloads that will be launching into geostationary transfer orbit. That means this rocket is going due east. There you go. You can see the mission patch, including those 4 stars, representing these missions that you see on your screen right now. You have the you've got UtilitySat. You've got hang on, I had the names. There we go. You've got UtilitySat. You've got NuView, Alpha, and Bravo, and I'm not sure if it's AGILA or AGILA. Those are the 4 satellites that will be on board heading into that geostationary transfer orbit. As mentioned, this is a launch that will be going due east on this booster B1083. As you see due east there, that means there are also recovery assets downrange, which they will try and catch this booster on the landing ship, a shortfall of Gravitas. So they will do that. Doug is also downrange to help recover the fairings. Hopefully that gets people caught up. And again, if you're wondering, hey, can I see this launch? Well, this is the best map for you. This is an idea of if you're in that red circle, go ahead and take a look outside at the T+ time on your screen. That is time after launch. And that is when there is a good chance you will be able to see it, weather pending, outside. So for people asking about Palm Beach, Fort Lauderdale, Miami, those areas, weather pending, yes, you should be able to see it shortly after flight. So keep an eye out. And once again, if you are out there, send us some stuff on social media, pictures, anything else that you get, videos, etc. If you have any other questions, tag us at NASA Spaceflight and we'll do our best to get you caught up on everything. And yes, West Coast Florida people, we know you're out there. It's just the weather has to cooperate for you as well. In terms of the satellites, Heisenberg's wondering, is UtilitySat a backup for the other 3, Alex?
Ooh, that's a great question. It's a backup, but not for the other 3. So on the Viasat mission, when they launched that mission, they were carrying, the Astranis satellite was a rideshare on that mission. And one of the things that happened is that, once they got up into orbit, it wasn't fully working the way that they wanted, right? And so it still works. They're still doing some stuff with that. But this UtilitySat was built sort of as a backup to that satellite when, because it was the first actual proper satellite. As you were saying, they had a demo sat on a PSLV from India, but that was like, CubeSat size kind of thing just to test some of the early technology and whatnot. That was their first proper big satellite, right? And so, of course, as you will do in any sort of, kind of program like this, where it's small, it's not this huge 5-ton satellite, you can probably spend a little bit more money and get a second backup satellite. And that's what UtilitySat was. It was a backup at the time for that. And now they're using it for this kind of mission to be able to, get that testing off, going and operating in different slots in geo and different frequencies and whatnot. Very cool.
There you go. Yes, and there was also someone asking, can they turn off airplane mode now with NuView-A and B? Uh,
Ah,
you saw from the patch, they actually had a little Wi-Fi signals going to the airplanes there.
yeah. I'm not so sure, but you can check that out once it's actually active. You can probably check with the airlines that are going to be using that.
Exactly. If they tell you to put in airplane mode, I guess technically you're supposed to follow it, but many planes do offer onboard Wi-Fi, so take that as you will. We are now coming up on 11 minutes until the launch. Here's a quick update of where we are at this point in the countdown. Right now, they continue to load RP1, which is a form of kerosene, as well as liquid oxygen into stage 1. As for stage 2, the RP1 has been loaded in there, and they are currently loading the super chilled liquid oxygen. With all of that super cooled, we get the frost, right, Julia?
It be frosty. That is one of the only times that these very well-used boosters actually look white again.
Yeah, and so for those who don't know, what is the frost?
What is the frost? Well, it's frost. I mean, super chilled liquid oxygen is really, really, really cold. And while here in Florida, it's well, relatively warm. It is technically winter here. I'm honestly only wearing a flannel with my t-shirt, so don't worry, we're not freezing. But relative to the air and humidity here, that means you definitely do get kind of a frosty snow cone like layer, which sometimes as you're watching this boost this you see the close-up views from the onboard cameras that SpaceX provides. You may see some of this kind of fall off of the booster. Launches are kind of violent that way. So don't panic. It's more often than not just ice you are seeing fall off.
Yes, a lot of people see smoke and get worried. As you mentioned, that is normal, and anything falling off is expected. This isn't a certain Chinese rocket where it has giant panels flying off of it, although, again, that's also expected. We are now coming up on 9 minutes until launch. Alex, everything proceeding so far?
Everything looking great. We are, that T-minus 9 minute point in the countdown. So far, so good. The next few things that we should expect is going to be that T-minus 7 minute point where they chill down the engines, right? And there you can see a view of those 4 satellites inside of the payload fairing. Those fairing halves, by the way, are not brand new whatsoever. One of them is flying for a 12th time and the other is flying for a 22nd time. We even know the serial numbers as well for that. I'm actually looking them up. There we go. 198 and 155. Those are the serial numbers for the fairing halves. They're now putting them in big numbers so we can now spot those, and that's kind of helpful, SpaceX. That was really cool. But yeah, T-minus 7 minutes, that should get our engine chill, and also few, like within a minute after that, we're gonna get as well RP1 load completed on the first stage. So just a few more steps down on the countdown.
And everything continuing to count down. I also love the little quadrant kind of deployer that they have for the 4 satellites on this one. And it gives you a really good size of scale for the payloads versus this, keeping in mind that the first one that was operational took a ride as sort of a ride share, essentially, on Falcon Heavy during the Viasat mission, right?
Yeah, that's one of the cool things, I guess, of this smaller version of the satellite, right? Where you've got a smaller satellite means you can either get multiple of these on your own mission, or if there's one of these bigger satellites, the big 5-ton satellites, you can ride share. You can just essentially go along because it's a 400 kilogram satellite. So it's not a huge amount of mass that you're adding to the stack, right? And in theory, you could do that as long as there's room on the fairing, of course, because there are some of these huge satellites that are flying nowadays to GEO that, frankly, there probably will not be a room. But hey, they found room on that Viasat launch. And so that's one of the things, because if you can ride share, you can also save money instead of having your own mission. But today, they got 4 out of on just one single Falcon 9, which, again, very versatile, I guess. Having more options is always a good thing.
Yes, and per Astranis, by the way, these 4 satellites, NuView, Alpha, and Bravo, will help boost mobility coverage over the Americas. AGILA will be the first internet satellite ever dedicated to the Philippines, and UtilitySat, as we mentioned earlier, kind of going up there to help that one that launched on Viasat, is the first ever multi-mission geostationary ComSat heading to Mexico to begin, and then can be moved around as needed, which is actually really, really cool, I
Yeah.
do believe. And we are coming up now. We are at 6 minutes, so at this point, Julia, can I get a final weather check for you before we let you go get ready to cover the launch?
Final weather check is, well, I think we might have some decent views for you tracking this downrange. It is still a bit breezy, but you know what? Nothing that's going to stop a rocket. I do not see said clouds that could possibly make a launch not ideal. So I think we're good. And I think I'll see y'all on the other side.
All right. We will see you on the other side. Good luck, Julia, as well as Max and Dee out in the fields as well, providing the views for the launch. So as we continue now, 5.5 minutes, we're about a minute away from the strong back retracting. That is that giant metallic structure that you see dead center on your screen. And Alex, that provides a lot of utilities to the rocket.
Oh yeah, you've got things like the propellants for both stages. Well, the Stromback does not give propellant for the first stage, but it does give nitrogen conditioning for the and purging for the raceways and also the intrastage. You've got also on the fairing, you have another quick disconnect to provide air conditioning and things like that. Excuse me. And yeah, there's a ton of connections. Of course, power as well, because you need to get some telemetry, power to the satellites, to the rocket, and whatnot. Lots of things there, and of course, you want to clear that out a little bit before you command those engines to ignite, and then at liftoff, that Stromback will throw all the way back and clear the way for the rocket.
There we go. So at this point, the clamps that are around the underside of those fairing halves opening up and retracting to that 1.8 degree. And yeah, that provides a lot of lifelines in addition to, for the rocket, it also even provides data lines as well as sort of air conditioning, so to speak, for the payload, keeping a steady environment for those 4 satellites that are launching on this Astranis from one to many mission, hopefully in 4 minutes. Again, 4 satellites on board that's heading to geostationary transfer orbit. You are looking at booster 1083 at Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. This booster is set to land on a drone ship downrange, a shortfall of gravitas, about 8.5 minutes after liftoff. If you're anywhere around the Florida area, now if you have clear skies, would be a good time to head outside and see if you can see the launch happening momentarily. As Alex mentioned, we have a few more milestones coming up here before liftoff, including wrapping up of all the propellant loads, the computers taking onboard control of the count at T-minus 1 minute, and then hopefully a liftoff. As this is the second attempt for this particular mission. The first attempt aborted after engine ignition. They swapped out the booster, which is why we have the one that you see here on screen, and are set to try again in under 3 minutes. So next up should be starting to wrap up some of those propellants, right, Alex?
Yeah, we should be very momentarily, seeing that wrap up of the first stage liquid oxygen load. Then the second stage liquid oxygen load will be about a minute later. We'll see that comeback of the Stromback vent. And I just heard stage 1 lux load is complete, so we've got that first stage is now completely loaded. Again, a few more seconds on the second stage, but we're getting there.
Exactly. So that is LOX load complete. Coming up next will be the finishing up of propellants, everything fully loaded in, and that big vent to indicate all is good to go. So let's keep an eye out as we get confirmation of stage 2, liquid oxygen loading complete. Again, this vehicle with liquid oxygen and RP1, rocket propellant 1, which is a refined form of kerosene on board. Also, don't mind the numbers on the side there because this launches at midnight exact Eastern.
Oh, yeah.
And there is that vent, so that should be a good indication for the confirmation.
Yeah. I just heard a call out that indeed the second stage liquefaction load is complete, so propellant load has been wrapped up on Falcon 9.
There we go. You can hear it's a little breezy out there, but everything continuing on. The next major milestone happening in about 20 seconds from now. That is when they will pressurize those tanks to flight pressure, and you will also hear the call out, or you'll hopefully hear, that Falcon 9 is in startup. Once Falcon 9 is in startup, that means that the onboard computers have control of the remainder of the countdown, and will be monitoring all of the systems to make sure everything is proceeding towards liftoff, and if needed, can stop the count. We obviously hope that doesn't happen, so Falcon 9 should be entering startup just about now. We'll get confirmation of that.
And they are in startup.
Falcon 9 is
There you
in
go, you can
startup.
hear some of those vents.
And there we have good confirmation that Falcon 9 has taken control of the launch count, and its tanks
Next
are
up
being
will be the go for
pressurized
launch, hopefully.
for liftoff today.
LD, go for launch.
There we go. We have the go for launch and the return of Chris G to NSF. There we go. 30 seconds now at this point. Again, we will stop talking once we get liftoff. The sound does take a little bit of time to get to our microphones, which are just under 2 miles away for this launch. So expect some great sound, hopefully about 15 seconds from now. Main things to keep an eye on will be the ignition of those engines using something called TTEB, which you might see a green flash. That will be followed by engine ignition at T-minus 3 seconds, followed by the launch. We'll keep an eye out. That is engine ignition and liftoff of Astranis from one to many, and it is on its way. Love the sound of that crackle, and you see the views there. We have DUIs as well as Max Evans, each providing a view for us with that split screen there. Also, the vehicle passing through Max Q, that is the maximum aerodynamic forces pressing down against Falcon 9 as it makes its way up. What views we are getting tonight.
The clouds are making for quite a show.
Yes.
Not thick enough that we cannot see it, but, you know.
Exactly. And the plume expansion, where it looks like it's getting brighter and wider,
Wow.
totally normal as it gets to the thinner parts of the atmosphere.
Looks like a meteor. Look at that.
It's just spectacular views tonight. Now, coming up in about 15-ish seconds, we will have a couple events in rapid succession, starting with MECO, or main engine cutoff, when the 9 Merlin 1D engines will shut down. That will be followed by stage separation of the first and second stages, followed by ignition of the Merlin vacuum engine on the second stage. So let's keep an eye out for those 3 events. That one being MECO. Our camera's a little bit ahead of SpaceX's, so you will see a slight delay from our views versus the SpaceX views that we have here. So we know MECO happened. Spoiler alert. There's MECO. That
No
stage
stubby?
separation? No.
The good nozzle.
Yes, the full Merlin vacuum engine igniting in SES-1, second engine start 1. And there we go. That's what we like to see. Again, our ground cameras continuing to track. Shout out to the team at the Cape tonight. Fantastic views between our actual cameras with people operating them as well as the robotic cameras. This one operated by Gauge remotely. I love technology.
Ooh, look at that.
And that is from D, and you really get an idea of the plume expansion there. As we talked about the thinner parts of the atmosphere, things definitely tend to spread out more, less focused, and you get that gorgeous view. Now, this is different, though,
Oh.
from a jellyfish.
There's the fairing separation. I was gonna say we saw that as well. I saw the little dots from the fairings because they get illuminated by the MVAC exhaust, and so you could see the lights of the fairing halves. That was cool.
Great views tonight. Absolutely great views. And that first stage now should be approaching, known as apogee, basically the highest point in its trajectory momentarily. So you'll see there that the speed is going down, the altitude going up in the bottom left. That is about to change momentarily. You will see the speed and altitude basically go stationary, and then the speed will pick up, the altitude will go down as the first stage continues on its trajectory towards a landing on the drone ship, a shortfall of gravitas located downrange, a little over 600 kilometers downrange. And that is apogee right there. You can see everything freezing. Speed goes up, altitude goes down. We don't want to see that on the right telemetry, which is stage 2, which you see on your screen there. That we want to see the speed continuing to go up the whole time, and so far it is. So next up, we will have a couple of burns, right, Alex?
Yeah, so we should be getting close to that entry burn about a minute from now. That you can see still tracking that MVAC engine. It's the one that it's moving.
That is D, continuing to track it.
Yeah, still tracking that. You know, I always get amazed because it's really hard to track these things that far downrange and this far into the mission. But yeah, we should be coming up on that entry burn on the booster. That'll be a 131 burn where you're gonna see one engine first, then 3 engines, and then down to 1 for the shutdown, and finally that center engine will fully shut down. That entry burn allows the booster to slow down a bit as it comes down for that entry. And also it protects the engine base, you know, the base of the rocket from the heat of the reentry.
Fighting fire with fire, as we like to say here.
Exactly.
And so that should be coming up shortly. And yes, by the way, as someone who has tracked these launches, this is extremely difficult, especially given many times it is out in the field, the weather conditions, bugs, as well as not having the same screen size that we might be having at home or using a TV to watch it. It is not easy, and an amazing, amazing job by the team. And there we go. Here comes the entry burn.
Single engine and 3 engines.
You can tell as it creates that sort of line of fire there as opposed to just the single engine. And this should go for a couple more seconds. Also, you can get a great view of the grid fins there. Those will help steer the vehicle as it gets into the thicker parts of the atmosphere here.
Down to 1 and shut down.
There we go. So now there's 1 burn left for that first stage, and that is set to be the landing burn where it will hopefully touch down on a shortfall of gravitas to be reused again.
Yeah, and as you can see there on the timeline, this mission is a bit different from what we see on Starlink, right? This mission will have SECO 1 first, second engine cutoff, that MVAC engine will shut down first, and so that second stage and the satellites will enter a parking orbit in low Earth orbit, and around that same time, then the landing burn will begin on the first stage. So it's going to be different order. Usually, you know, for Starlinks, first the landing burn, the booster lands, then we got SECO, shutdown of that MVAC engine, but this way it's different.
There you go, and there is our favorite
Empty
view,
pad.
the empty pad, as we get ready for that landing burn coming up shortly here. There's the good views of the second stage. The first stage now only 5 kilometers off the deck of the drone ship. So we should be coming up on SECO 1, second engine cutoff 1. And there we go. That is the shutdown of the Merlin vacuum engine for the first time for tonight's mission. You can see the payloads there. We're waiting for a review from SpaceX from the booster. There it
Shutting
is.
down its MVAC engine, stage 1 is performing its landing burn, heading toward a shortfall of gravitas.
We'll see if we can maybe hear some sounds from the drone ship in addition to the little dulcet tones of Chris.
Landing leg deployed. Stage 1 landing confirmed.
And there is
Touchdown! A successful landing. You could hear the engines on a shortfall of gravitas. The sound on that was spectacular. Julia, what was the sound like for the launch on this one?
Well, the safest thing I can say on a family-friendly live stream is it was loud. Like, feel it in your chest. Definitely, feel it, your feet on the ground. Loud, and it was very bright. We don't joke around when we say it's our midnight sun rising, because it was pretty much nighttime straight into daylight around here. And I hope you guys all enjoyed those views as much as I did.
Oh, we very much did. Thank you to Max and Dee. Julia, hopefully you enjoyed the view. I know that you guys need to roll out. So, Julia, thank you as well for your commentary tonight, as always, and Happy New Year.
Well, thank you, Sawyer, and everybody. Stay tuned tomorrow for us to put any imagery and video that we captured up.
Yes, exactly. Keep an eye out on all the social channels as well. You'll likely see them there on X, on Instagram, on Facebook. I believe we're also on TikTok. There's plenty of different opportunities to check us out on the socials. We're at NASA Spaceflight on most of them, so you can check those out for yourself as well. So thank you. And we are going to continue to hang here with you for a little bit longer because we still have satellite deployment to go and one more burn, right, Alex?
Yeah, so right now the second stage is coasting in that low Earth parking orbit and, waiting for the right moment to be able to light that second stage engine again at T plus 26 minutes. That is essentially when the second stage will be over the equator. And that way the apogee, the higher point on the orbit will be also over the equator, but on the other side of the globe, right? And so that burn will raise that apogee, will raise that highest point of the orbit out to the geostationary belt, essentially. And so that way they are able, these 4 satellites then are able to, more efficiently change their inclination. Because right now they should be in about 28-degree inclination orbit, right? More or less the same latitude as the Florida launch site. And so you need to go from 28 to 0 because that's the equator, right? You have to go over the equator to be truly in geostationary Earth orbit. And so there you can see the map. Thank you, SpaceX, because that illustrates the whole point much better. And so you need to go right over the equator. And the best way to change your inclination in an orbit is when you are on top of the equator. So if you have your apogee, your highest point, right, out there in GEO and everything, you want to change that over the equator. So that's why they do the racing burn when they are over the equator, because then the other side will be also over the equator, but on the other side of the globe. And you'll still have that inclination a little bit, right? But you'll have that highest point over the line of the equator. We'll probably have to make a video about that. But if you played Canaveral Space Program, that's usually the way that you will do it.
So you're writing that one, correct?
Well, no, not at least not anytime soon. But in the future, we'll see when we can do that. But yeah.
Yeah, and as you pointed out with Kerbal, the Kerbal Space Center is pretty much at 0 degrees on the equator there. Florida is one of the closest spots you can get to the equator from the United States. hence why that was partly chosen as a launch site in addition to the Cape sticking out away from people. At the time, it was just a waste. It was kind of like a wildlife area. It still is a wildlife preserve there. So that's kind of why they chose Florida. It's close enough to the equator.
To be able to truly experience this sort of thing of needing to coordinate when to burn and everything, you need to launch from the other launch site, which I don't remember right now, and nobody ever uses it. But if you launch from there, it's not exactly in the equator on Kerbin, on Kerbal Space Program. So if you launch from there and you want to go to Kerbal stationary orbit, I guess, then you do need to align your orbit so that it's right over the equator and everything. Yeah, to change your inclination. But a little bit of orbital orbital mechanics, I guess, here on NSF. But you're bound to have some of that. We're covering launches, right?
Yeah, and fun fact, that is also why the International Space Station, and part of why it is in the orbit that it is in, is because the way the orbit works, it lines up neatly to be able to launch from Kennedy Space Center or Cape Canaveral Space Force Station in Florida, as well as the Baikonur Cosmodrome in Kazakhstan, so that both Roscosmos and NASA can launch to it.
Oh, look at that.
Gotta love the view there. That is D set up at the KSC press site, taking a look over there at Pad 40. Look at the skies for that. It was beyond perfect for this launch. And the sound, spectacular, which we did have a question here. 98 Central asking, does the humidity in clouds have an effect on the sound from Falcon 9 engines? Awesome rumble. Yes. Very much. Yes. The sound waves are certainly affected by the conditions in the air. When it tends to be more humid, the sound kind of hangs a little bit more, I guess is the best way to describe it. And because the air is so thick, the sound lingers. It almost like it hits you a little bit stronger. So as much as the humidity is awful to be in, it has a fantastic effect on the sound and the way that you feel the launch. And you can just tell from the replays there, as gorgeous as this all is here, spectacular. And the clouds, sometimes if the cloud deck is low enough, you'll get the sound kind of reverberating a bit from a thick cloud deck. But humidity, a big factor there. This is the view from Fleet Cam that we have at Rusty's over in Port Canaveral. It's weird not seeing Falcon 9, multiple Falcon 9s there right now.
Yeah, right now there's only one, but hey, that's still rare these days, right? Because they just store them out there, and it's crazy.
Yeah, it's a only one.
Yeah. Yeah, I gotcha. When you said that, I knew what you meant.
Exactly. Oh, love when it punches through the clouds, that
Look at
glow
that.
there. Also, shout out, by the way, to Kevin and Michael Reed with the split screen views tonight of the launch from all of our cameras. That was so stinking cool.
That was cool. But that was
Yes.
also enabled by having, multiple people at different locations. So shout out to people in the field, D, Max, and Julia. So
Yes, Max and Julia located at a viewing site provided by the Space Launch Delta 45, which is the Space Force. D at the Kennedy Space Center Launch Complex 39 press site, which are both on opposite sides of each other. So technically we had 360 of the rocket there.
yeah,
Max with one side and D with the other.
guess we should try that more often, right?
We got to have Space Force provide us views that way more often.
That's true.
That works.
Yeah, you're not wrong.
This is a view also from our robotic cameras that we also have at the press site there, which I was told that Gage tracking that remotely via a cell phone.
Yeah, that's new. I knew about the trackpad, but that's new.
Yes, laptop trackpad is one thing, but to be able to track it on a phone is... I love our team. That's all I can say, is how much I just love our team. They're really good at what they do.
Look at that. It really looks like another sun.
And that's the thing, talk about night into day, as Julia was saying, with the midnight sunrise. It is. It's one of those things where, yes, of course, the cameras give you a good idea of it, but until you're there in person and see a night launch, you don't really get just how bright it is. It does feel like day for about 30 seconds there as it lights up the sky. Right before it goes into the clouds, especially when you get a cloudy launch like that, it kind of spreads it out. It's like, oh yeah, just the sun went behind a cloud. No, it didn't. That is a rocket propelling 4 satellites into space for Astranis on the From One to Many mission. And these also are Cape cams that we have.
More gauge.
Yes, that give us views of the port as well as Blue Origin's pad. And these tracks to the east. River Dave, yes, I would say Gage phoned it in on this track.
Wow.
I'm jealous that I didn't come up with that. Well done, River Dave. But yeah, this is being tracked by Gage from a phone. Spectacular work. And again, just the colors for tonight's launch were beautiful. I want to say more, but I'm watching with you. It's stunning. And this, of course, the max view from 1.8 miles away, I believe, is the number. So very, very close. Again, thank you, Space Launch Delta 45, for offering this viewing opportunity. Let's listen into it again. I don't want to talk over it. I just love being able to listen to that. That was a great one tonight. Max, huge W's in chat for Max. That was really well done tonight. And W's for D as well. I guess 40 of them. Would that make that WD 40? But that was terrible. But still, the Cape team out there, spectacular work tonight. Mad respect for Max and D. And again, the plume expansion going through all the clouds. I love when you get clouds that are just thin enough that you could still see it. And then you get a good idea of that plume expansion, seeing like the 9, you can almost see all 9 individual engines there. And then we have our other view as well from D. Which they came back from a trip, went to the Cape, and then provided views. They are also spectacular, rolling out like that. Love it. Absolutely love it. D pointing out they are running on just 3 hours sleep in the last 2 days, basically. So, thank you. We are now less than 5 minutes away, by the way, from the reignition of the Merlin vacuum engine and what's known as SES2 as we continue to watch a replay of the climb uphill. So we kind of briefly were talking about that that's kind of curve there. You could see it really well on the map coming up.
Yeah. That's another feature of this burn. So more orbital mechanics ahead, but long story short, not only you want your apogee to be over the equator, but also that is when the most, the further away you are, the easiest it is to change your orbital inclination. However, you can still spend some of that performance and change the inclination early on. So this burn will not only increase the apogee, that highest point of the orbit, but also change the inclination. That's why you see that sort of dogleg kind of shape there. Sort of like you will see on a dogleg when launching, but it's already in orbit.
Yeah.
So it's going to change that inclination.
By the way, the reason it's called a dog leg, for those wondering, it's
It
because
looks
you've
like
ever
that.
seen a dog all curled up and their arm is bent, all adorable. It looks just like that.
Yeah. And that vent that you can see there, that's engine chill. So they are chilling down that MVAC engine ahead of that burn because it's going to burn again, right? And so they're going to be pumping liquid oxygen through that liquid oxygen to a pump. And so they need to condition that for the burn. So,
same as they do for the 9-1Ds, same as they do prior to the first Merlin vacuum ignition, right?
Yep. Pretty much the same. You just don't see that when they burn the first time because it's inside of the intrastage, and there are these little tubes that allow all of that to come out of the intrastage instead of venting inside of the intrastage.
Yeah, also they don't usually give us the views of inside the interstage until stage separation.
Yeah.
Hey Chris, if you're watching, any possibility of that? I'm kidding. We're about a minute away from that burn, and we're not talking a super long burn here, are we?
If you compare it to a Starlink mission, it is long because
Oh,
on
yeah.
Starlink missions they do a second burn. It's like 1 second. You blink and you miss it essentially. This one is about a minute long, 1 minute and 5 seconds at least from SpaceX's timeline. One other thing that also usually happens around this time ahead of that burn is, they have these RCS thrusters, right, on the second stage. And not only they can adjust the attitude, the pointing of the second stage, but also they are able to settle down those propellants because they are in space. They are in 0G essentially. So they are able to settle down those propellants for that engine burn. Should be happening in less than 1 minute from now.
Yes, and those flecks you see falling off, by the way, are ice still from the super cool liquid oxygen, so that is totally normal.
Yeah.
I'm sure you're sick of hearing
That burn
Alex
should
and
be
I, so
coming
how
up
about
in
for the
about
burn,
30
we listen
seconds
to
from
former
now.
NSFer Chris G.
You can see great views of Falcon 9's second stage here being lit by the sun as our second stage has passed into orbital daylight. And as always, you can follow along with the speed increase that this burn will impart to Falcon 9 on the bottom right-hand side of your screen.
Watch for the ice to melt when the engine ignites.
Boom.
And there
I
we
love
see
that.
the ignition of the second stage MVAC engine. And as a reminder, the ice that you saw around the engine nozzle there at ignition is normal.
You think that we learned the same lines at some point here? Sounds familiar.
Again, this burn will last for just about a minute and put the second stage into the proper transfer orbit as it prepares to deploy the 4 Astranis satellites on board.
So Chris, people should check out shop.nasaspaceflight.com, right? Indeed. You can see speed and altitude continuing to pick up there in the bottom right, as Alex was mentioning, that sort of dog leg, in addition to increasing the apogee, or the highest point in the orbit.
Yep. That speed really going up and up. Should be coming up on that shutdown very shortly.
Chris, let us know when it's done. How about that?
And right on schedule, you see the shutdown there of our MVAC engine for second engine cutoff 2, or SECO 2. With that, we are almost at the finish line for today's mission, but we still have one final coast to go before we begin deploying the 4 Astranis satellites on board today. This will be a short coast, so don't go anywhere. We'll be back with you all in about 5 minutes. See you then.
It is so strange hearing Chris G on NSF again. He
It
hasn't
is.
changed. I mean that in the nicest way possible. He hasn't changed.
But
That's
there you
exactly.
have it.
I feel like that's exactly what he would have said if we was
Oh,
at NSF with the. But we're not done yet. We
look
still
at
have.
that.
Absolutely beautiful.
Well, if they keep this feed, we're gonna enjoy some great views.
Indeed.
Ha! Okay, I got that.
Little tribute there, even the y'all in there. So, and yes, again, as we were told by the company themselves, it is Astranis. So, Chris, check your pronunciation. Again, we say this all with love. We still love Chris Gebhardt and all that he did here at NSF and all that he's doing over at SpaceX. So, nothing but love. So we come up now on 30 minutes since launch, which it's crazy. All these times where we talk about it and we, start normally would be wrapping things up. Here we're continuing to cover everything. It feels so fast in comparison. Am I not wrong?
Yeah, it is. It is quite quick. One of the things that I like about these GTO missions is precisely that, even if you stay around for deployment, the deployment occurs very quickly after launch. Like it's just, within 30 minutes, 40 minutes, you're done. And so it's very nice. We should be getting, so since it's 4 satellites instead of 1, we're going to get 4 deployments for one mission. That's quite a great deal, right?
Four for 1.
4 for 1.
That's
Yeah.
our that's a holiday special, only available until the new year.
Hey, better than, I don't know, 60 for 1 with Starlink, but that's actually one single deployment, to be
I was
fair.
gonna say that's all at once. I think we're talking more like a bandwagon type mission.
Oh yeah, ooh boy, yeah, transporter, bandwagon, those really stay up there deploying their things for a while. And if instead of going to GTO you go to, I don't know, GEO instead, then you're going out there for a few hours.
Yeah, that's the transfer orbit versus direct into geostationary orbit, for those wondering. This one does the little transport, and then the satellites work themselves into their final orbits, as opposed to Falcon doing all the work for them. I mean, come on, they can pull their own weight, right? Yeah, hopefully we'll get the awesome quadruple deployment, obviously not all at once, as you can see there on the bottom of your screen as well. For the timeline, there are 4, so it is expected to be UtilitySat will deploy first, followed by NuView Bravo, then NuView Alpha, and then AGILA. I apologize, I still don't know which it is of those 2.
Yeah, and you may see there on the telemetry, the altitude goes up, speed goes down. That's normal. More physics or mechanics, I guess, but as you go up on your orbit, you slow down a bit. You can sort of think about that as if you were throwing a ball or something like that. If you can imagine the ball's perspective, it's going to be slowing down as it reaches the top of that arc, right? And then it's going to accelerate as it comes back down. So the same thing happens on an orbit. It's now already accelerated its way out, and with that burn, and now it's going up in altitude and going down in speed, trading off both.
There you go. Always love a good physics with Alex lesson from Alex Physics 13 themselves.
The other day there was some chemistry mission. I think it was on the Flame Trench show, and
Yes.
somebody was pinging me, and I was like, "I'm Alex Physics, not Alex Chemistry."
Yes, asking about unsymmetrical.
Methyl hydrazine, I think it was, right?
And the
Something
how
like that.
Ryan Caton, when trying to make up one sort of random chemical compound that wasn't, he actually ended up by accident making one that was technically the same. So yeah, just kind of funny there. So yeah, that deploy should be coming up. Hopefully we'll get to see all 4 of them And again, hopefully Chris Gebhardt will be able to tell us exactly when they deploy and all of that. So we'll continue to listen in for once Chris tells us that deploys are coming up. Of course, we're still with you here the whole time here at NSF. So don't worry, Alex and I and Kevin are still around. I don't know if that's a good or a bad thing, but we're still around. By the way, Dr. Holly, thank you. Yes, next time we will make sure that we take you up on the offer to double check our chemistry. So that first deployment,
and we are
about
about
a
30
minute
seconds
away
away from the deployment of UtilitySat, and we
We're 30
hope
seconds.
to have a good view of it, which you can see here on your screen.
Thanks, Chris. So that a couple seconds away. Any second.
Astranis GS-002 separation confirmed.
And there goes our first deployment for the UtilitySat today. Now, the first...
There we go. There's one. 3 more to go. Next will be the 2 NuView satellites. And these are all spaced out by exactly 1 minute, by the way. So that one occurring 33 minutes and 45 seconds after launch. The next one, 34 minutes and 45 seconds after launch, followed by 35, 45, and 36, 45. Ish.
Ish, yeah.
Again, the numbers that are provided by SpaceX are approximate. The actual numbers are based off of real telemetry and the data being received from the vehicle. So if things happen a little quicker or a little slower during launch, maybe the engine burns a touch hot, that's when you'll get the numbers slightly off.
With the one on the right
Astranis
here.
GS-004 separation confirmed.
That's NuView Bravo. So far, so good. 2 down, 2 to go. Again, I love this little quadrant shape that they have for the deployers for this. Hopefully, we'll get the feedback. There it is. Gorgeous view of the Earth below as well. So yes, NuView Alpha is next, followed by the final one, AGILA. And that's just a couple seconds away here.
Yeah, this is the neat thing, that it's a very short time between deployments. It's just 1 minute in between.
And
So
you can
this
see
next
great
one should
views
be-
here from Falcon 9's payload cameras of Earth there in the upper part of your screen, and one of our 2 remaining satellites to be deployed down
That's
in
what
the
we were just
lower
saying.
right-hand side of your screen.
Astranis GS-003 separation
You got it.
confirmed.
And gorgeous. Indeed,
You could see
that was a
the
beautiful one.
you can see the Hall effect thruster on the back of the satellite that it's going to be using for inserting into GEO. They have electric propulsion, so they use some kind of noble gas or something like that, speed it up. You got ion thrusters essentially.
And we'll keep our eye on the final satellite set to deploy in about 25 seconds from now. And there it is. We will have the view, it looks like, of that final deployment. We will listen in to the dulcet tones of Chris Gebhardt and the team in Hawthorne getting ready to deploy these.
Astranis GS-005 separation confirmed. All payload operations confirmed.
And
There we go. All payload operations confirmed. All 4 satellites deploying. That sounds like a successful mission for Astranis from 1 to many.
And hopefully many, many more. That was a successful launch for Falcon 9, entire mission from liftoff to satellite deployment. Happy customer, hopefully.
Yes,
That's
and
always good.
it's also great that we actually get views of the full deployments. We don't get to see that super often. So that was absolutely stunning as we take a look now at the empty pad at Space Launch Complex 40, where that rocket stood just about 36-ish minutes ago. Now, the second stage, Alex, what's going to happen to that again?
That's going to be what they call passivated, essentially all of the remaining gas, all of the batteries. So the gas will be vented, the batteries will be drained, and so all of that will be just, made as inert as possible so that, there's no unexpected explosions in space, essentially. And it'll stay in that orbit, eventually it'll come back just because of atmospheric drag. Ooh, we have a replay here.
Yes, we'll take a look at a replay as we wrap things up here. Reminder, there is one more Falcon 9 launch scheduled this year, and that should wrap it up for SpaceX in 2024. That is the Group 12-6 Starlink mission that is set to launch at midnight Eastern tomorrow. So that would be, well, technically today, however you want to count it, December 30th, 12 a.m. Eastern from Launch Complex 39A at the Kennedy Space Center. Hopefully we'll see you for then. Alex, thank you so much for your assistance with commentary tonight.
It's been a pleasure, and of course, while the while the year changes, the launch cadence doesn't really change at all, only just up. And so we're gonna get another launch on New Year. So that's gonna be January 1st. There's another launch from this pad. So yeah, 3 days of turnaround time. That's gonna be fun, but we'll see what we do for that.
Not too bad. And again, our Cape team doing spectacular work tonight. We had Julia helping out with commentary out in the field. We also had Max Evans, both of them rolling out to Space Force, and D-Wise providing us views from the Kennedy Space Center side. So a huge shout out to the team there. And of course, getting us some awesome, cool split views and fun things for tonight, Kevin Michael Reed producing the stream. So a huge thank you, Kevin. I've been Sawyer Rosenstein. A happy new year to everyone out there. If we don't see you for tomorrow's launch, hopefully we will. Make sure you subscribe, hit the notification bell so you know when that launch stream goes live. Until then, see everybody later. Have a good one.
And here we go. We have liftoff.
Propulsion continues to be nominal.
RCPA chamber pressure looks good.
Doubling up. Roger, roger, Atlantis.
Water towers fly! Yes!
Tango down to nominal.
Flight downside SPD off. Bring in SPD off. It's orange!
Oh my god! Oh my god!
Decollage. Put that in the big bag.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting in the flare, correct?